Today I am going to make a battery modification to a popular wireless gaming headset, the Logitech G930. Before I start, let me warn you that if you do this, this will void your warranty. So be warned, it's on you alone if you mess something up and it doesn't work anymore. So to start with, we are going to need one of the Phillips screwdrivers from all of those screen replacements that you have done, and remove the screws. How many were there? Let's find out together. So they are quite easily accessible from...
Yeah, we don't have to remove anything.
There you go. This is the cushion removed. Now we need to remove additional screws to get inside the headphone. And don't go into the one with all the buttons, that is the wrong side. The battery is on the other side, the right side. Now let's see. Here is the original battery. The original battery is rated at 600 milliamp hours. And we are going to replace it with this one, which is rated at 2100. Before I continue, I want to do a measurement to see how much current is this headphone using while it is running on its volume turned all the way up. So it looks like it is drawing 75 milliamperes when it's volume all the way up while playing, and now it has fallen to 51 when it's just in standby and nothing is coming in. So this is what we can work with when calculating how long will the new battery last compared to the previous one. I'm going to do the modification now using some common tools, because I don't want to use too much fancy stuff, because then nobody can repeat it easily. Here are some cutting snips that you can get for a few dollars, and some common pliers, and let's see how well can I do with these. Now the other battery that I measured and selected for this modification has just big enough size to fit inside here, as you can see, and it is a little bit thinner than the previous one, so there should be a little bit room for the protection circuit, because this battery is protected but this isn't, and I am not going to guide anyone to an unprotected modification, because as we all know from Samsung reputation, batteries can be rather dangerous. So we need to remove this fence around here. Let's get on with it. I just got really close to the surface, and this kind of pliers are really good for this. As you can maybe see, they have a very flat cutting surface. Here there is a little bit thicker piece of plastic. Must be careful not to break the tool. Let's do the other side first.
Careful here not to cut your wires. You will need those.
I will use a little bit bigger snips here. This was really strong part. You definitely need something stronger than these, but you can do the cleaning with these to make it nice and even. Now let's clean this up and let's see how the new battery fits inside here. First we need to, I have already soldered the connectors on here, and I believe I have a clip of this that I'm going to add around here, and now I am going to bend those wires down and tape the connections until we are going to use them, so that nothing too sparky doesn't happen while we are fussing around here. Now let's see. All this must fit in here, and this connector too. As you can see, the battery fits in here, and all the sides are properly connecting. Doesn't even move inside here, so we don't really need to add much in terms of cushion, but we will add a little bit. Now this proved that it fits in there, and we don't need to do any modification on the case just removing these sides and it's complete. Now what we need to do is wire the new battery to be used instead of the old one. Now a little bit about protection. This battery has a protection circuit inside here that I can't show you, but it is in here, believe me. This will protect the battery from being too discharged and overcharged. Especially the overcharging is the most dangerous part. That may make things go boom and fire. Now, since this battery doesn't have the protection circuit because it's meant for the phone and the phone has its own electronics, we need to add the protection to be sure that it's safe. So I'm going to use the protection circuit that is usually meant to be used with protected cells that are of this type. Those are the lithium ion 18650 cells. Now some of these have the protection circuit, and this is usually mounted in the bottom here, making the cell a little bit longer. Now since it's pretty small, we are able to fit it somewhere inside here without much of a problem, I believe. We can do a little test by putting it on top of here and seeing if it can be sitting on top of here, or do I have to hide it somewhere on the sides. So let's find out. As you can see, it did fit in here and there is no cap, so there was enough room on top of the cell to mount the protection circuit right there on top of it. So we don't have to do anything too fancy wiring it to I don't know where, and we can do something simple on top of here. That's good, making our life and modification easier. Let me tell you about this. This is marked with B- and P+, and this bottom side is the output minus. So the protection sits between B- and P+ and protects the current used through this bottom plate. So I need to solder an output wire here, and this will go into the black wire here, and we will find out if we have to do anything with the middle wire, or will this headset function without the middle wire. Now what I need to do next is cut these wires one by one to get this connector to make our life easier. So let's acquire this connector. That was plus, that was minus, and that is the yellow one. Now I have the connector wires. We need to clean them up. A little bit of soldering paste makes. Then we need to connect this one to this one and this one to this one, and well, it doesn't show really well, does it? Well, there is the B- that goes to battery minus, it's the blue wire here. B+ goes to battery plus, Now, like I said before, from the underside we are taking the output minus into that connector, and from the plus we are taking the plus side that is shared between those two. Let's do the bottom one near the side that it has to be later on. Now it's connected here. Let's test it strong. Yep, it's strong. It shouldn't be connecting to the top side, of course, so be careful. P plus goes here. Since soldering on top of a lithium battery isn't the most wise thing to do, then don't do it. Okay. Don't follow my not best practice example. Yeah, well, now this is connected there, and these three can meet here, and then we have our circuit, because P minus goes here, P plus goes here, P plus to the device goes from here to here, and minus goes to the device from the bottom side, that you can't see, but it's under here. Black on black, yeah. If you are less experienced in soldering, then definitely don't do things like I did right now on top of the battery. So there, connected. The connector is on the side, and as you can see, this connector can be pulled on the side here very easily, where it should have enough clearance to be connected. Now let's remove the extra . Let's use some tape. That is one very thin Captain tape. Now this will protect from overcharging and undercharging this battery. This is what failed inside Samsung Galaxy Note 7s. The circuit that was supposed to protect them. And so the batteries went, well, boom. Okay, now we should do some testing. Now, chipping in from the future, where I have completed testing without the middle wire connected to the yellow. It did indeed show the charging LED, but it didn't start blinking, and I used my USB logging device to see if any energy is getting used. Is the battery getting charged, and it didn't. So the internal circuitry doesn't actually charge the battery unless there is the signal it requires from the middle yellow line, and the signal it requires is a 10k resistance signal, which I figured out by measuring the yellow to black resistance on this one, the original battery. So this Samsung battery has in the middle to black, middle to negative, 2.5 k resistance, but we need 10k or around 10k. So with what I found was this 6.8k resistor, which was the closest to the 7.5. Anyway, because any other step would require two resistors, I just picked this 6.8k and it worked. So we need to wire this into the middle wire on this circuit, and then it starts charging, and I have already tested and it works. One other thing that I want to mention is if you are putting this on top of the battery and then pressing on top of this with the case, then I really recommend that you check that when you don't make the underside, don't leave any pointy solder spots to the underside that you will then press onto the battery, because if you press for a long time too much into the battery, you might damage the layers in here and cause problems. So what I did is just soldered a thin piece of, well, the same thing that you can cut from these ends on the bottom here, and then soldered a wire on top, so the bottom side is pretty nice and even. Okay, now to the resistor. We need to wire this from the middle to the yellow, and the way I'm going to do this, because I have a bare wire here, I'll just put it under here, bend it next to it, and solder it here, and then the yellow one here, because the connection will be on the side anyway, so it doesn't have to go anywhere, and it doesn't touch anything else. Then that's what you need to make sure, that your connections are not touching anywhere where they shouldn't. Okay, let's get into it. Now if I charge it now, you can see it starts to blinking mean the energy is going in. Before it was just solid light and not charging. It might be rather full now and not doing anything because it's full. Oh no, it's still charging. I can see that it's right now drawing very little current in this upside down. Very little current because it's rather full, so the final bit is charged very slowly. So there you go. The little resistor can be found from your local Radio Shack kind of shop, or whatever is it called in your country, for a few cents. There. Semi-installed. Let's turn on. And let's play some music from the YouTubes. This is some music from the YouTubes. And it was working. Now, before I wrap this up, let's talk a little bit about this battery. I will link the battery name that I used here and that I researched and measured to fit inside here so precisely. I will link this in the description, where I will not link where I bought it, because this is actually a fake or used battery. I did the measurement on this. I will put it on the screen right now, and it actually only gave me 800 something milliampere hours instead of the 2000 it should have given out. So you need to be very aware that there are a lot of fake ones and used ones being sold that will not give out the 2000 that we are looking for. And if you cannot find a genuine one, then you are not winning much, because this has 600 and right now this has an 800, and that is a very little bit of improvement. But I am going to I already found a local supplier that sells the genuine parts, and I am going to ask a refund for this, because I have the test that you also saw, so I can show them that it was fake, and it cost me $5 or something. So this is usually, if it's very cheap, then it probably is fake. So if you don't have a way of testing and then showing the seller that it was fake, then you probably shouldn't buy those that are not trustworthy. If you can find, then try your local sellers. I will link in the bottom of the description of this video the mark and model of this battery and the phone it was used for, because there are also some aftermarket third-party battery makers that also make batteries for this Samsung phone, and those also can work because they have the same size and same connectors. But yeah, be aware that the eBay and AliExpress cheap ones are often enough just fakes that have less than half of the capacity it should have. And if you can't test it, then try finding a local supplier, because the phone batteries are not so rare commodity. Most countries probably have some local sellers that deal with those. And now let's put it together, and I will just replace this later on for my friend when I'm receiving the genuine one from the local supplier. Right now I'm just finishing the guide, and I will do the same thing later on with other battery. I actually found a LiPo element from my own stash that also had 2100 capacity that it also tested for, so that's what I ended up using this time. At the 75 and a little more milliamp rate, this battery should last around 24 hours and charge up from completely empty in around 5 hours.